thought I'd run off with the microphone. So in July 2019, the development of the Riverford mobile app reached a bit of a crisis point. So this slide might look familiar to some people. The PSD2 legislation came into force in September, and we were sort of getting ready to do all of the changes to the mobile app to make it work. It was looking like a hefty chunk of work involving some sorcery with web views and that kind of thing, but nothing too hairy, and it all looked kind of manageable. However, at the same time, our error tracker started filling up with these mysterious errors. And you'll see here that it's a completely minified stack trace with no way of getting back to the original source. We managed to get source maps working in development, but never in production, so the fact that we were getting thousands of these was a real problem. At the same time, we'd recently put out a major release which covered product availability over time, so it gave people the ability to do pre-orders, it handles sort of end of season and withdrawn items, that kind of thing. It touched a lot of the code base, it was a major change, and what we hadn't noticed is that it had created this performance regression, and with about 10,000 active customers at the time, this was another big problem, and we were starting to get emails into customer services, people were unhappy, and they were writing negative reviews on the app stores, which is a real pain. And then finally, the real bombshell was this surprise from Apple. We issued a routine update, which was just some changes to button styling, and we were rejected. And they stated guideline 5.1.11 that customers needed to log in to the app. We made customers log into the app, but we had to allow them to use the app without logging in. And we did have the work for anonymous shopping on our roadmap, but not for a while. However, with this rejection from Apple, it meant that we had to do what Apple wanted first before we could address any of the other issues. So this talk is about growing mobile apps with ClojureScript and React Native, which can sometimes be challenging. I'm going to rewind now to the starting point, where it all began. And as with many things in life, I wasn't actually on the scene when the idea for the app came around. So I did the logical thing. I asked my boss on Teams why we were building an app at all and where the idea came from. And it turns out that the seed for this app was just 3 words of a long list of 60 items that was given to my boss on his very first day of work. And it was to be, I don't know if you can read this, but it says here, an easy order app. And the reason for that was because the current website was proving sort of very cumbersome to use, and especially on mobile, and the directors wanted to have something that was sort of fun to use and very quick. So yeah, 3 words, and that was pretty much the brief, and we started work. In the beginning, after some sort of orientation, we ended up with a long list of things to do in order, as with many other projects you would see this kind of thing. Jira tickets, you know. But in the early days of ClojureScript and React Native, it was really a wild west. There are a few sort of templates here and there, but lots of things that have been abandoned. There was this file, this sort of mystical file called figwheelbridge.js, and none of us could figure out how on earth it worked, but it did work, and when it worked it was amazing, but sometimes it didn't. And I remember sort of my very first week on this project, I added a library to the sort of renatal template. It was a basic library, I think it did navigation or something like that. And I got this red screen of death, like nothing was working. So I did the logical thing, I took the library out, undid all the changes, but the red screen of death was still there, and I was already pulling my hair out, and it was only the first couple of days. Which leads me on to my first tip, which is to try this Expo. And Expo is this platform for developing React Native apps, And the nice thing about it is it kind of, React Native development is very fast, and there's a lot of kind of cutting edges, beating edges, and they take a bit more of a cautious approach, so they're maybe a couple of releases behind, but they pick all of the important security fixes and that kind of thing from the main chunk. The other thing that they do is they create this client that you can run your software on. So the main sort of way that Expo works is, instead of having the native code, the Android code and the iOS code in your project, you just have the JavaScript, or in our case, the ClojureScript code, and that gets bundled into a client if you build it on the server, or you can serve the code from your local machine to a device. It really makes it's sort of easy to use. It gives it like all of these advantages. The first one I talked about before, the platform is really stable, and 2 to 5 you really sort of fall out of the fact that you're only working with the JavaScript, and you can do all these kind of things, including code push, because again it's only the JavaScript that's changing. You can load that into the binary. So to get started with Expo, there's a Yarn kind of command-line tool which you can install, and if you run Expo CLI in it, you can start off a new project. It makes sense to use the managed workflow, in my opinion, because unless you're doing like really heavy native stuff, it's just not worth the difficulties that you get in the upgrade paths. And so when you start off the template, you can fill in his name and slug, and it will give you something that looks a bit like this. So this thing, I don't know how much of that you can read either, but it's called the app.json, and that's a place where you'd put a lot of the stuff that you would normally reach into sort of native code to do. So if you want to get deep links working, if you want to change a splash screen, various kind of properties of the native app, you would do it here. And then to kick it off, just run Expo CLI start, and you'll get something like this. This QR code, you can, once you've got the Expo app installed on your phone, you can scan that, and it will run the code live, and you can with a live reload and that kind of thing. So this is just JavaScript so far. The next kind of hard-earned tip is to try out Shadow CLJS. So, as I said, in the early days of the project, we were using this kind of figwheel bridge.js and sort of various bits and pieces bolted together. It was all a bit of a Frankenstein, but we were lucky enough that Clojurists Together funded Thomas Heller recently, and he did a lot of work on the React Native support in Shadow CLJS, and has really done an amazing job, and I can't recommend it enough. So the advantage you get from using Shadow CLJS over whatever else is out there, firstly, the hot reload is really, really good. Secondly, the external support is sort of mind-blowing. If you've used Shadow CLJS before, you'll be familiar with how easy it is to use libraries from NPM. It's just much more reliable. You can use a lot more of the NPM libraries. But yeah, really, I just can't say enough how more robust it made our stack. So to take the project that you've sort of created from Expo and convert it into a ClojureScript Shadow CLJS project, there's just 3 steps. Assuming you've got Shadow CLJS installed. You create a Shadow CLJS.eden, which looks a bit like that. There's a builds key in this map, and you provide the target of React Native, an init fun. If you want the good extern support, then I'd advise using infer externs auto, which will basically mean that the compiler will emit a warning every time that you use an object that needs an extern, and you can tag it in your code rather than an external file to get that extern generated. Step 2 is in the app JSON that I showed earlier. You need to add the entry point, so that has to match up with what was in the shadow CLJS.eden. And finally, you create the ClojureScript file yourself. That init point, init entry point there matches up to the one that was shown in the shadow CLJS.eden. And that's, this movie is just like the hot reload kind of working. So the final tip, those first two tips I can sort of recommend without hesitation to anyone trying ClojureScript and React Native. The third tip is probably a bit more divisive, but it's something that we found really beneficial as our project sort of got to middle stages. So if you haven't come across Tachyons before, it's been described as a subatomic design approach. So you construct these little units of style, so for example, like little bits of padding, little bits of margin, little bits of text shadow, colors, that kind of thing. And then you combine them together to get a kind of integrated, consistent feel across the app UI. And for us, this proved to be really a middle way. So in the beginning, I tried to match the designs exactly as they came across from the designer, and there were a lot of sort of font size 9 and padding 18, that kind of stuff, so it was spread all over the place. And it was very easy to tweak and to get the designs exactly right in one place, but what we lacked was the consistency across the whole thing. And then later I tried sort of the other approach, which was to try and like have a name style sheet, but that ended up being brittle, and although it was a bit more consistent, it was very, very hard to tweak the elements when they were sort of different from one another. This worked out well because we had a restricted set of options that could be composed together in sort of infinity of ways. So it looks a bit like this, the original kind of inline styles, just in full at the top, and the modified sort of Tachyons version is below. So each one of these keywords corresponds to a pair. So for example, AIC there would be Align Item Center, FG1, FlexGrow1, JCC, Justify Content Center, and the font sizes, the paddings and margins all had like a specific grid. Gave us these advantages, as I kind of mentioned before. There's less code, consistency is better, and it's easier to modify. On the subject of less code, this is what we had before. This is just one of the screens being changed. You can see we were able to delete a large number of lines and make the code kind of easier to understand. So the development of the app kind of proceeded in this way, with the back-end team working on the API and us consuming the feature, and so on, until we found ourselves back at the point which I mentioned at the start, facing the 4 Jira cards of the apocalypse. So I did what anyone would do in this situation, you know, what I've been jokingly referring to as the stack of doom. I thought, well, is it true? Is this the stack of doom? Is this all a bad idea? But the thing is, when you're halfway up a mountain in a cauldron, hanging onto a rustic oak table with a hammer, it's not the time to start questioning how you got there. So we did what was the only thing we could have done, which was to break out the minified JavaScript. So this was us trying to track down that range error that I mentioned in the first couple of slides. And you know what? It was quite fun. We started to understand the matrix in a way. And although we didn't solve the problem by copying bits of minified JavaScript into Notepad, we did. I think it was the willingness to copy minified bits of JavaScript into Notepad which was the key to our salvation in a way, because before we tried looking outside us for the answer. So there were supposedly these things that could merge two source maps together, but none of them worked, at least not in our case. It was a ClojureScript source map and the JavaScript to JavaScript bundler source map. But having done our time with the Notepad and Unified JavaScript, we were able to build a very rudimentary but very useful tool, and that's available on GitHub. So this thing, source map CLJS, will take two source maps. That's the source map from ClojureScript to advanced compiled JavaScript, and the source map from the advanced compiled JavaScript to the bundled JavaScript that is consumed by React Native, and it will traverse back to the original source, and that can be enough to dig you out of a hole. So that fact, combined with this, I don't know if probably you've all seen this Stuart Sierra's blog, so this blog post about misuse of concat was enough to help us solve the problem. We were foolishly using concat in a reduce, and we were building up this sequence of operations, and when the sequence of operations got large, we were overflowing the stack. So thanks, Stuart. Won't do it again. So that was one down. Next up was performance, which has always been kind of my weak point. I find with performance-related stuff that I'll profile it, and then I'll find something really promising to change, and I'll make the change, and then I'll end up with something that performs worse than what I had in the first place. And then I repeat the process 10 times and end up with something that's 10 times worse than what I had in the first place. So it was with some trepidation that we began this work. But again, I think once we really started digging into it, and we had a couple of guys on it, we were able to make some progress. And there's 4 main ways that you can sort of troubleshoot performance issues in React Native. The first one for kind of UI issues on Android is really great. There's a systrace tool, and it can expose things like when bitmaps are taking too long to send or to compose, or if the shadows are causing you problems. And that helped us identify an issue with text shadows, which were sort of delaying the frames, and helped us remove a bit of jank. The second one, I never actually managed to get this working, but supposedly you can spy on the bridge between React Native and JavaScript, and that can sometimes be a bottleneck in code because a lot of information has to go across this one native bridge. Third one's probably the most useful general purpose tool for debugging, so you can run your JavaScript not in the device but through Chrome, which means you can use the Chrome tools, including the debugger and the profiler. And finally, again, like rudimentary hand tools, which you can knock up yourself. This is the Chrome profiler in action. So I don't know if you missed it, but on here you choose to debug in debug JavaScript remotely or something like that. I found that it won't always pick the right sort of JavaScript process to profile, so it's best to go into this bit here and select the debugger worker.js just to make sure you don't get this blank page profiled, which is really pretty boring. Then when you press record, it will profile the JavaScript, and you can choose to display it as a flame chart and look at it in the way that you normally would. This was really, really useful for us, and gave us a couple of big wins. Firstly, removing moment.js. There was a bottleneck in date parsing, and replacing that with date funds really helped improve one of the really hot code paths. And secondly, it showed some places where we could add memoization. And again, it really helped us improve the performance. it also flagged up a place where one of the components was getting rendered more than we thought it should have been. And that was the time to turn to the trusty print line re-rendering, print line here technique of debugging, because it really shouldn't have been re-rendering. So what we did is we captured the props or the relevant bits that shouldn't have changed in Atom, inspected them at the REPL, and found out that these two maps that look the same were not the same. And then after doing like a keywise compare on the maps, we found out that it was the price that, although like it was $11.95 in both, was not comparing equal. And of course that was because we had a custom JavaScript type to represent decimals, and they didn't compare equal. And so with just this small little clip of code, we sorted out not just that component, but any other of the component that had price as one of its properties. And together with all of the other work, that was enough to wrap it up and call it a fix. So that was block number 2 down, and I think blocks 3 and 4 just got scared and ran away. So I guess what the sort of metaphor that I'm going for here is that developing an app is a bit like growing a seed. There's a few phases of growth. In the beginning, when a seed grows, like it's in a sort of little self-contained bubble, and it's got all the resources it needs to survive, all the various proteins and amino acids and that kind of thing. And it happily goes along inside there, thinking it knows everything about everything. But it reaches this point here where it's consumed all of the resources inside the seed, and it needs to break out to reach the actual soil. And I imagine for the seed that's a pretty stressful time, and for us in the growth of the app, well, for me especially, it was a very stressful time. And I guess the message is sort of don't give up, because if you get through the crisis point, there's another phase of growth possible afterwards, and it's a better one, hopefully. So with that in mind, I've put together a little demo app which contains a whole load of useful bits and pieces if you're going to try to make an app of your own. So it's got the Expo, Shadow CLJS, and Tachyons that I talked about earlier. It's also a little bit experimental, so there's some React hook stuff in there. There's hooks for storing stuff in async storage of the device. There's keyboard avoiding view, there's navigation. And the app itself is a kind of dream diary, because dreams are kind of like seeds, and you can ignore them, or you can like plant them and like try and nourish them and get as much as you can out of them. So yeah, that's that. So having gone through this whole sort of process and all of the various troubles that we had, it may seem like it's not really worth building an app. So I had to put this side in to say it is, and although I questioned myself a lot, like because we were developing a website at the same time, it's like, do we really need an app at all? Like, why can't we just use a website? So I think there's 3 big reasons for building an app. First one is that you get access to stuff that you wouldn't normally in a website, or it's a lot easier to access. So stuff like the barcode scanners, the cameras, the geolocation, accelerometer, all that kind of stuff is exposed by APIs that are easier to work with. And secondly, the UI, second part 1B is that the UI components are a lot more suitable for building apps with. So working on the web, I've often struggled with getting a modal overlay to work on iOS Safari, and I always find that it ends up scrolling the background instead of scrolling foreground, and it's a real nightmare. But that kind of stuff is a real joy to do on in React Native, because they've got the right components there and they just work. Secondly, sort of more business reason, is that you get this sort of brand awareness just from having an app. So people pick up their phones an average of like 80 times a day or something like that. And space on that home screen is valuable real estate, and it just reinforces your brand almost passively. On top of that, you have the ability to send push notifications if you want, and the presence in the iOS and Android app stores. But I think the biggest reason is that it's just kind of fun. You can get into this real state of flow with apps, and especially with some of the things that I talked about earlier. I really think it's one of the best ways of taking an idea, like a seed, and growing it and sort of trying out the idea and seeing if it's got any merit. So my original plan was to end with a seed bomb. So if you're familiar with the seed bombs from gardening, like this little cluster of seeds that you throw into some patch of ground, and they all sprout up, and they're lovely little wildflowers. And I was going to have like this list of ideas, and they were all going to be great, and they'd be like little seeds. So if you didn't know what you wanted to work on, you could like pick something that you could try out. But none of my ideas were that good. So I was lucky enough that the conference team kind of outdone me and provided a real life seed bomb. So you can plant these. They've got the little seeds in, and I thought that was just a really wonderful thing.
Oh, there we go. Anybody got a quick question for Daniel? Oh, we got one over there.
Hi, I was wondering if you could just expand on the idea of it being good and rapid for prototyping, because obviously earlier in the talk, one of the problems you had is a rejected app, which means that you can't push it into the market, and that seemed to be a problem you were having, and then by the end you're like, oh no, that's the best way to do it.
Yeah. So you're totally right there. So there is the issue of the gatekeepers, especially Apple, who are sort of notoriously strict and kind of just almost random in what they will choose to reject. So when I said for rapid prototyping, I guess I was more referring to the development of the idea. So you can still run for yourself, or at least in the kind of early phases of developing an idea. In the same way that Clojure is kind of good for rapid development, because you've got that kind of REPL fast feedback cycle. But yeah, you still have to get past the guardians.
So with the hindsight of the app that you've worked on, do you think that using ClojureScript was worth the extra layer that you have between you and React Native, as opposed to just using vanilla JavaScript?
That's a really good question. I like using Clojure, so for me, and like we were a Clojure team more than a JavaScript team, so it made sense within our team to use Clojure. But honestly, I don't think you'd lose that much by using JavaScript. But if you're familiar with Clojure, like, I think it just makes it go faster in a way that Clojure can do. And I don't think the problems that we faced tended to be not in the Clojure realm. They tended to be in like the JavaScript to JavaScript kind of realm. So I don't think we lost. Well, I think we gained a lot by using Clojure.
So when you were developing ClojureScript, did you find that you were actually using the kind of REPL-driven development type workflow at all? Because just from personal experience, my experience of ClojureScript versus JVM Clojure is do it all the time in JVM, but there's quite a barrier to it being as useful as some of the other tools, like even print debugging sometimes on the Node platform. So, like, how do you guys work, and how have you found that?
Yeah, so again, another really good question. So I found the REPL really comes into its own on ClojureScript when you're debugging. So we had a really nasty issue recently with like just the database sort of not restoring, but I was able to. We didn't have any reproductions, but then my boss had it happen on his phone, and I was able to get the database off of his phone and then load it into my emulator, and then using the REPL sort of step through the various functions that were called on the database and work out exactly where there was a problem. And I think without the REPL, that would have been a really difficult thing to debug. But yeah, not as much as on the JVM. It's more something you reach to when there's a problem, or for me.
All right, thank you very much. Another big round of applause for Daniel, please. Thank you.